A.C. Verma, chapter Semiconductors and Semiconductor Devices. Question number 12. It is chapter number 45. They are telling to estimate the proportion of boron impurity which will increase the conductivity of a pure silicon sample by a factor 100. Assume that each boron atom creates a hole and the concentration of holes in pure silicon at the same temperature is 7 into 10 to the power 15 holes per cubic meter. Density of silicon is 5 into 10 to the power 28 atoms per cubic meter. So what is actually its meaning? Its meaning is when there was no external impurity added, that means no boron is added, then out of 5 into 10 to the power 28 atoms per cubic meter, there was 7 into 10 to the power 15 holes per cubic meter, and obviously as it is intrinsic, pure, and as in pure semiconductor, electron concentration and hole concentration are same, so the electron concentration was also 7 into 10 to the power 15. You got it? I told that out of 5 into 10 to the power 28 atoms per cubic meter, there were 7 into 10 to the power 15 holes per cubic meter and 7 into 10 to the power 15 electrons per cubic meters, because it is an intrinsic or pure semiconductor. That is, we can say that out of these 5 into 10 to the power 28 atoms, out of these 5 into 10 to the power 28 atoms per cubic meter, electron was 7 into 10 to the power 15. It is electron concentration, and obviously the hole concentration is also 7 into 10 to the power 15 per cubic meter. So I can say that out of this 5 into 10 to the power 28, the total number of electrons and holes which were contributing to the conductivity is this plus this, that is 14 into 10 to the power 15 per cubic meter. So 14 into 10 to the power 15 electrons and holes together were contributing to the conductivity. That means still maximum number of electron holes, maximum number of atoms were not contributing to the conductivity, Look, total is this number of atoms, but how many are contributing? 14 into 10 to the power 15. So how many still not contributing? This, which is a very big number, very big number. If you take common 10 to the power 15, then it is 5 into 10 to the power 13 minus 14. Is it clear? So this is, you can neglect this. So almost the conductivity was nothing. Why? Because if you neglect this, it gives us again 5 into 10 to the power 28. So it is a very less conductive. That's why it is called semiconductor. Now let us get back to the problem. What IC Verma is telling, due to the mixing of boron particles, what happens? The conductivity increases by a factor 100. That means conductivity was due to this 14 into 10 to the power 15, right? Before mixing of boron. So it will increase by 100. So it will become what? 14 into 10 to the power 15 into 10 to the power 2. 100 means 10 to the power 2. So the new total number of contributing electron and holes together becomes 14 into 10 to the power 15 into 10 to the power 2 means 10 to the power 17. This is the new number of electron holes contributing to the conductivity after what? After mixing of borons. So let me consider, out of here x number of holes are there. So how many electrons are there? The remaining baki 14 into 10 to the power 17 minus x. So x is what? I am considering out of the new concentration, x number of holes are there, and so the remaining are electrons. And we know that, what do you know? We know that this relation is always applicable. Intrinsic concentration square must be equal to hole concentration into electron concentration. Intrinsic meaning concentration before mixing something, it was 7 into 10 to the power 15. 7 into 10 to the power 15. Intrinsic means pure, virgin. Nothing is mixed, nothing is added up. So it is now x into 14 into 10 to the power 17 minus x. Is it clear to you? Have you understood this? Okay, the relation is 10 to the power look, this is the relation, right? Okay, intrinsic concentration square is the new. So solving you will get x. Solving you will get x. So what is x? X, what is x? What is x? X is the new concentration of hole. X is the new concentration of hole. And so X is the concentration of what? I can say this is the concentration of boron, right? And boron is the external factor. So solving this, I have to get X. So after getting X, I can say that X number of boron should be mixed. When X numbers of borons are there in 5 into 10 to the power 28 silicon. X number of borons are there in 5 into 10 to the power 28 silicons. So one should be there, one atom should be added out of 5 into this. In Hindi, X नंबर ऑफ एटम बोरोन एटम होना चाहिए किसमें 5 into 10 to the power 28 सिलिकॉन में. तो फिर एक बोरोन का एटम होना चाहिए 5 into 10 to the power 28 बाई X एटम में. तो ये इक्वेशन से हम लोगों को X आ गया. जब आई हैव गॉट X, पुट इट हियर. सो एक बोरोन एटम कितना सिलिकॉन में ऐड करना चाहिए वो आ जाएगा. दिस इज़ द आंसर. इट्स अ ब्यूटीफुल सम.